Hi, and welcome to our presentation of electricity and magnetism in motors. This is Group 10. Here's on the agenda for today. We're going to have electric motors, electricity, real-world examples, motivations, physics, the current, magnetism, and circuits of electric motors. Starting off, we've got electric motors. Electricity can produce magnetism, and magnetism can create electricity. This happens in an electric motor when it spins around. When charges from one piece of matter interact with those from another piece of matter, they produce both electric and magnetic forces. These forces help electric motors to turn in different directions. So, what is electricity? Electricity is the interaction of electric charges. Electric charges are a fundamental property of protons and electrons, which make up every atom. Positive and negative charges are the two types of electric charges. Protons possess a positive charge, whereas electrons carry a negative charge. So here are some real-world examples. You've all seen Teslas. That's normally what people think of when they think of an electric motor. Electric cars. And then you've got things that you use almost every day. You've got elevators, vacuum cleaners, house fans, even power tools and parts of robots are electric motors. And like I said, they're used in everything we use daily, almost everything. And just very, very cheap and implemented widely.
So for the next topic, we have motivations. And so the main thing we described or talked about is companies that motivate us and what they do. The first one is Tesla, which you heard talked about already. They started with electric cars, and now they mainstreamed into, almost everything. In the sustainable energies field, one of the biggest ones is aerospace and space travel. The other motivations that we see are Regal Rexnord, which have pushed sustainable energy and electric motors into the agriculture and industrial fields. These are big motivations because electric motors strive to preserve the earth and ultimately to stray away from these harmful fossil fuels. We also want to have more of a sustainable long-term energy source since fossil fuels will, go extinct soon. And the last big motivation for us is to make energy more affordable to everybody because of gas prices or just the electrical bill in general going way up. The next thing we'll talk about is how electric motors work. The physics side of things, this is the start of it. The main formula that we can use, there's a lot of them, but the main one is F, which is magnetic force, equals the current times the current length of the wire times the magnetic field. This equation shows that the moving charges in a wire are affected by the magnetic field, which will cause torque leading to rotation. That torque goes through the electrical flow through the currents. Electrical motors are made up of a bunch of wires and electrical currents with them flowing through them. These wires and electrical currents sit between the north and the south magnetic fields. As the current moves through the wire, the opposite side of the magnetic field will make each side of the wire feel an opposite force, which pushes them in an opposite way, creating torque. Electrical current, there are two types of it, DC and AC. Direct current is a type of electricity where the charges flow in only one direction. Batteries are an example of this. But the alternating current is the important one here. Like I said, there's two fields of magnetized force which push them in the opposite direction. What is magnetism? Magnetism is when a force can attract or repel certain materials. So if you look on the right here, it says charges like to repel. So you'll have a north on one end and a south on the other end, like the bottom right, which they attract, which will have these electrical currents being pushed toward each other.
Okay, and lastly, we have our magnetic field. So that would just be the region around the magnet that is affected by the magnetic forces. And so typically you may see, maybe you put a magnet, you push them together, and they might push off one another, but some magnets might attract each other and stick. We have parts of the circuit. So for circuits, we have the energy source, which is an electric field created by a battery that is positively and negatively charged terminals that attract and repel charges. We have the load, which is a component of a circuit that consumes electrical energy to perform a function. You have the wires, which are low resistant conductors that carry current in a circuit connecting components, materials, and thickness that are selected based on the distance and the current or the voltage. And yet lastly, you have your switch, which is the circuit that connects and disconnects the power between the two pieces.